Okay, this is the video for lesson 6.1 on differentiating trig functions. Really, it should be called differentiating trig functions 1 because we're actually going to do this over 2 lessons. Warm up here, I would recommend that you try. It goes back to unit 1, but it's always good review to look back at those previous units as well. And this little picture here is actually going to be really useful for something we're going to look at in a second. So we got the graph of sine x here, and labelled on here you can see tangents given at certain points, and you can see positive slopes here, zero slopes, negative slopes, and so on. And we'll take a look at that in a second. So just to check, this is what we should have covered in the previous unit. So the question asks, did we cover all of these? And hopefully you can go through and agree that you did. And anything that you missed is something you should go back and make sure that you're aware of. Strictly for Unit 6, this is what we're going to be looking at. Specifically in today's lesson, we're going to be focusing on derivatives of sine x and cosine x. And we're going to be able to differentiate a variety of trig functions also using the chain rule. So although it says sine and cosine here, we're also going to be looking at other functions, which is why it talks about that down here. So that graph that you saw a second ago, I've recreated it here, not quite as nicely as that one. And what we notice is, if I actually plot the derivative of sine x, as in what is the slope, so this y-axis here is the slope at this point. So at 0, we notice that the slope was 1, or that's certainly what it said on the original picture. At 90, the slope is 0. So I'm not plotting the coordinates here, I'm plotting the slopes. So I'm plotting the dy by dx, essentially. At 180, it was negative 1. 270, we can see is 0. And 360, you can see is 1. Now, I haven't plotted every single point here, and technically if you looked at this, you might think that this is actually just an absolute value graph. If I was to plot more points, what you would actually notice is there is another trigonometric graph that you know that also passes through those points. And although I haven't drawn it very elegantly there, hopefully you would recognize that as cosine x. And that's actually one of the rules. The derivative of sine x is cosine x. So not a great proof, but just to give you some idea of why the differential of one is the other. That will help you to try and determine where some of these results actually come from. Now these first three results are actually given to you on the formula sheet, and then the f dash of x, the derivative, is listed alongside them. So you don't need to remember these ones, you just need to know how to use them. Now, unfortunately, probably the ones that are the more difficult ones to remember are the ones they don't give you. So the differential of secant, cotangent, and cosecant x. And I have to be honest, these two here I often get mixed up, so I have to make sure when I do this unit that I check carefully which one is which to make sure that I don't mix them up. Of course, in reality, most of the time while you're working on these exercises, you're going to have a look at notes or you're going to have the formula sheet in front of you, and you can just check to make sure that you are using the correct rule. Now, we can also extend this if we put an extra term in here. So all these questions were just sine of x. So what happens if we change it to like sine of 2x or something like that? So what actually happens for those questions is we differentiate this term here. So the differential of a number with x, so like the differential of 2x would be 2. Differential of 5x would be 5. So the differential of ax would be a. And then we just use that rule from the previous page. So differential of sine is cosine of the same thing. So they both say ax here. Differential of ax again is a. Differential of cosine is negative sine of the same thing. And that rule extends for all the other terms that you can see on here as well. As we start to make these questions with numbers, just to make them look a little bit more realistic, rather than just these generic questions, then we actually use the chain rule. I know we tend to think of that as just the parentheses questions. We actually use chain rule for this question as well, because we kind of have to do two things. We have to differentiate the 3x, but we also have to differentiate the tan. So they're kind of connected together, giving us this chain here. So when we looked at tan on the previous sheet, and I actually put it at the top just for this first one, differential for tan is secant squared, so of the same thing. But also we differentiate what the f of x is as well. So the differential of 3x would be 3, which is why we bring this to the front. If you check for secant, you would see that it's secant tan. So secant tan of the same thing, as in 5x, and the differential of 5x is 5. And for cotangent, the differential is negative cosecant squared of the same thing. And then the differential of 3x minus 1 is 3, and then we can put it all together. So as you can see now, this is starting to get a lot more complicated than what you were used to with just polynomials, in the fact that already there's 6 different rules here. 3 you can just look up on the formula sheet, and 3 you actually have to remember because they're not going to be on the formula sheet. But also remembering what to do if there's a number here as well. The fact that we're going to differentiate this term and bring that to the front, as well as doing the differential of sine is cosine as well. So it definitely starts to get more complicated. And then, of course, it does start going more complicated still. So when we have questions with trig formulas like this with exponents, remember what it actually means is this. So this is probably more what you'd think of as a chain rule question, something raised to a power like this. So those same rules, if we want to differentiate it, we bring the power to the front, keep this the same, decrease the power by 1, and then times by the differential of what's inside the parentheses. Now, as we get to more complicated questions, to write that down in words, we actually put d by dx. So I still have to differentiate this thing here. So rather than trying to do it all in one step, we just say we are going to differentiate what's inside the parentheses. Then we can start working out what that actually gives us. So the differential for cosecant was negative cosecant cotangent of the same thing. And the differential of 3x is 3. And then from here, I can start to combine terms as well. Negative 3 times 4. I can see I've got cosine 3x cubed, and I also, cosecant 3x cubed. And I also have another cosecant 3x here as well. So I could combine those as well to make cosecant 3x to the power of 4. So a lot of little steps on these as we're doing questions, which is why it becomes more and more important that you guys show steps on your questions so you can see actually how well you're doing on this. This is probably where you should pause the video. In class, we're going to spend about 2 minutes on this. So have a quick try on this one. Pause the video and then unpause after 2 minutes. So hopefully you recognized it as a chain rule question. So we bring the power to the front, keep this term the same and decrease the power by 1. And if you use that same notation again, we differentiate what's inside the parentheses, but we just write that out rather than working it out at one go. So the differential for cosine is negative sine of the same thing. And the differential of 2x is 2. And then like the last question, you can start to combine terms here. 3 times negative 2. Not much else we can do here, really. We certainly know identities for these things, but that's only going to add in more terms. So this would be the most efficient answer at this point. Now, also linking back with Unit 4, we can also have questions with logs and exponentials that also have trig functions in them as well. So if we're doing the log of sine squared x, remember first of all what that actually means. And then we could start to use that rule for logs. So the rule for differentials with logs is it's the differential of this over the original thing. So to differentiate this, you would bring the power to the front, decrease the power by 1, times by the differential of sine x, all over what the original thing was, which was sine squared x. Now the differential of sine x is cosine x, so we could certainly put that. I wrote sine squared out here, and I can cancel the sine x on top and bottom, giving us this. And of course, cosine over sine would give us cotangent. And quite a complicated question. There's a lot in that question, as in we have to remember the rules from logs from Unit 4, but we also now have to know what the differential of a trig function is as well. Now, as we're doing these questions, we should remember something important from that last unit, which was, is there a rule of logs we can use when we're doing these questions? So for this one, there was. If I have the log of something raised to a power, remember I can just bring that power to the front. And then suddenly this question's a lot easier now. So as I differentiate the ln of something, I differentiate this and put it over the original. So the differential for sine is cosine, put it over the original, which is sine, and then cosine over sine, you can just write as cotangent straight away. So clearly that's a lot simpler than what we did here a second ago. So once we're doing those questions with logs, certainly think about, is there any rules we could use? So this one says differentiate this here, and show your answer can be written like this. So as it's a log question, I should be thinking about rules for this. And I remember for my division questions that I can say it's the log of the numerator minus the log of the denominator. And then each question I can just go back and answer independently. So this one we actually answered in Unit 4. So the differential of 3x plus 2 is 3. And then put it over the original 3x plus 2. Differential of tan x is secant squared x, and then we can divide that by tan, which was the original term. If necessary, we can try and simplify this term here to see if there's anything that simplifies. So I wrote secant squared as 1 over cosine squared, and I wrote tan as sine over cosine. I know when I divide by a fraction, that's the same as times in by the reciprocal. I could certainly cancel a cosine out from both of these as well. And the other thing as I'm doing this is remembering we're trying to get the answer to look like this as well. So as I get to here, 1 over cosine I know is secant, and I know that 1 over sine is cosecant. And then actually I have managed to prove exactly what they wanted us to do for this question. As we're working through questions as well today, sometimes you're going to have this from Unit 5, which we saw, the sum and difference formulas. And sometimes you're going to see this as an answer, or you're going to get this as an answer. But when you check in the back of the book, you're going to see this as an answer, and you might not immediately be sure that you've got the same thing, particularly as one's sine and one's cosine. So remember, if we do our rule, we can say it's the sine of the first one, cosine of the second one, minus cosine of the first one, sine of the second one, like this. Sine of pi over 2 is 1, cosine of pi over 2 is 0. As this is 0, this whole term disappears, so we just get cosine x. Now, the reason this might be useful is later. If we're asked to differentiate this, we could certainly use the chain rule, but it might be kind of complicated. If we know that this is just this, then actually I can write this one down straight away. The differential of cosine x is on the formula sheet. It's just negative sine x. So, if you have the choice, and I know this doesn't follow PEMDAS or GEMDAS very nicely, I would always try simplify first and then differentiate, rather than differentiating and then trying to simplify. So I wouldn't differentiate this and then try and simplify each term. I would simplify the terms first and then I would differentiate if it asks you to do something like that. A lot of rules today. There will be more rules coming up in future lessons as well. This is the one unit where it's really important that you try and stay up to date with those rules. If necessary, try and keep them all in one place so you've got somewhere where you can check back to. And keep looking over those rules whenever you get a few minutes just to try and solidify them in your mind so you'll remember them better. And that should do it for lesson 6.1.